Okay, so in this video, we're going to talk about finding the direction angle. So what I mean by that, let me draw one. If I have vector 3, 3, means I'm going right 3 and up 3, right? So I'm going from here to there. So what it means is I'm looking for the angle from the positive x-axis counterclockwise to the vector. So I'm looking for this little area right here. So let's see. If I'm going to do that, I have a triangle right here of 3, 3, and here's my theta. And this is a right triangle. So I'm going to use tangent because I have an angle here and I have the opposite and I have the adjacent. So I'm going to go tangent theta equals 3 over 3. Remember, if I'm solving for an angle, I have to use the inverse function. So that's what I'm doing right here. So that's going to get me theta to equal 45. Now, if I think about that a little bit logically, that's very familiar to me. If I have, for example, a right triangle such as this one, if this is 3 and this is 3, I know that if these are equal, it's a right isosceles, that both of these are going to be 45 degrees. So this answer makes perfect sense. Now, when we start going into different quadrants is when it gets a little crazy. So let's try this one. We will try 3, negative 4. So I'm just going to draw it out so you have a visual. I'm going to go right 3 and down 4. So here's my triangle. I always want to go from the vector here up to the x-axis. So what I've got here is 3, negative 4, and again, here's my theta, that inner angle. The angle that you're going to use to find all of these is always going to be the angle that's touching your x-axis and the origin. So what I have here, same thing, tangent, because it's opposite over adjacent. Here's my opposite, here's my adjacent, negative 4 over 3. So that gets me theta equals tangent inverse, negative 4 over 3. So when I take that and I put that into my calculator, tangent inverse negative 4 over 3, I'm going to get negative 53.13 degrees. Well, what I just found was from here to here. But what I need is this whole thing right here to the vector. I'm going to clean that up a little bit because I drew that a little far. There we go. To the vector. So I don't need this. I need to subtract that away. Well, 360 degrees minus theta, what I have here is going to go ahead and get rid of it. Well, it's already given to me as negative, so I have a negative theta plus 360 degrees. It's the same thing. Remember, when you're adding and subtracting, that order matters where your subtraction sign is. So here, if I have negative 53.13, I can add 360 to it, and that's going to go ahead and get me 306.87 degrees. And that seems really reasonable because right here is 0, 90, 180, 270, and 360. This number is between 270 and 360, so it seems pretty reasonable. So in this quadrant, if I'm here in this fourth quadrant, I'm going to add 360 to whatever I get from my tangent. Now, what if I'm in, say, I don't know, this second quadrant? If I'm in the second quadrant and I have negative 6 and 7. So let's draw that out. 1, 2, 3, 4, 5, 6. It's not pretty. 1, 2, 3, 4, 5, 6, 7. It is very hard to draw on this touchpad, I'm not going to lie. Okay. So from here to here, this is negative 6 and this is 7. And again, here's my theta because it's always the angle touching the x-axis and the origin. So I have tangent theta equals 7 over negative 6. So then I have theta equals tangent inverse 7 over negative 6. I'm going to take that, I'm going to put it into my calculator, and I'm going to get back negative 49.3, well, negative 49.4. Negative 49.4. Thank you to rounding. So that means from here to here, this angle is negative 49.4. But I need this angle. I need all of this. Okay? So since this is negative, and this whole thing, if I was to go the entire way from here all the way over, that's 180 degrees. So I'm going to take this sliver, the green, I'm going to take it away from 180. And that's perfect because it's already negative. So I'm going to add 180. Once I add 180 degrees to that, I get 130.6 degrees. And that seems pretty reasonable for the amount that we're looking for in this blue right here. This whole blue area, that seems reasonable because it's bigger than 90 and it's less than 180. 130.6 seems very reasonable. All right. If we're in the third quadrant, so if I have negative 7 and negative 4, if I have that, let's draw that out. I'm just going to draw a picture. And we'll say that this is negative 7 and this is negative 4. Here's my vector. So what I'm looking for again is right here inside that one. And so what I've got here is tangent theta equals negative 4 over negative 7. If you haven't noticed, each time you're doing this, it's always going to be your y over your x. Every single time. Tangent theta equals y over x. Here's my y, here's my x. So I'm going to go theta equals tangent inverse negative 4 over negative 7. So I'm going to take that, put that in my calculator. Do you have to keep the negatives? No, I just do for consistency. That's going to end up getting me 29.74 degrees. So what I found was this. But what I need is this whole thing. So I need all of this, the green plus the red. So that means I'm going to add 180. So once I add 180 to that, I get my theta is equal to 209.74 degrees, which again seems reasonable because here's 180 degrees and here's 270 degrees. So it's less than, and then it's greater than 180. So you're right where you should be. So the rule of thumb that you have for any time that you're graphing any of these, or not graphing, but you're solving for the direction angle here, you don't do anything. Nothing. You just take the tangent, theta equals y over x. You just take that, and whatever you get, that's your angle. Because you're going to get a number from 0 to 90. And this is 0, and this is 90. Over here in this quadrant, you're going to add 180. Over here in this quadrant, you're going to add 180. Over in this quadrant, you're going to add 360. The other option you have is, say, for example, in this one right here, if I got negative 49.4 and I don't want to add 180 to it, I just feel like that's just weird and I just don't like doing that and I like to make things more challenging for myself, I can do 180 and I can just do 49.4. I can take 180 and I can take that number away from it. It's more effort in the calculator. I like to do things the easiest way. Adding 180 works. All right, so this is finding the direction angle. So remember, you're always going to have a number between 0 and 360. You go counterclockwise from the x-axis, the positive x-axis. And your theta is always going to be touching that origin and the x-axis inside of your triangle. So you always go out from the origin for your vector and down to the x-axis, or out from the origin for your vector and up to the x-axis. You're never going to the y. You always go to the horizontal. Okay? Let me know if you have any questions.